We finished our introduction in the last video. Now we're going to get into naming ionic compounds. After this video, you should be able to identify polyatomic and monatomic ions and name them correctly, and write the chemical formulas and names for ionic compounds. So since all compounds are neutral, you need to figure out how many of each ion is needed to make a neutral compound. And recall that neutral means having a net zero charge. For example, if I wanted to make a compound between magnesium and chlorine, what I would have to do is I would have to look up the charges of each. So, for example, when magnesium combines chemically, it is going to have a +2 charge. And you know that because it is in group 2, and those elements have a tendency to lose 2 electrons. Chlorine, however, has a tendency to gain 1 electron, and therefore is going to have a -1 charge. If you look at this now, you can see that these charges are not equal to each other. If you put this compound together and just wrote MgCl, that wouldn't work because you would have an overall charge of +1. What that means is you need a second chlorine. That way, the +2 here will equal out the -2 here, and what you'll end up with is MgCl2. This number is a subscript. It represents the number of atoms that you have of the chlorine. If you want to do the same thing with aluminum and oxygen, again, you would look up the charges, and you have to probably say to yourself, what number can both 3 and 2 go into evenly? So in this case, we would need another aluminum and another oxygen. But if you put the compound together right now, you could see on the left-hand side with aluminum, it's +6, but on the right-hand side, it's -4. So this compound still can't go together. It's still not neutral. So we're going to have to add another oxygen. So that now on the left-hand side, we've got a net of +6. On the right-hand side, we've got a net of -6. When you add them together, it equals 0. And so because you have 2 aluminum and 3 oxide, you're going to have Al2O3 as the compound. Here's another example. If you look up the charges for calcium and sulfur, it's going to be Ca+2, S-2, and so that's pretty easy. It'll just be CaS. Finally, you've got a polyatomic ion here, but don't get scared because you handle it the exact same way. The good news is all you have to do is look on the back of your periodic table to find the polyatomic ion sheet. So you'll look up the charges for calcium just like usual, that's +2, but then ASO4 is on the polyatomic ion sheet and it's called arsenate, and it has a -3 charge. Again, +2 and -3, they don't go together. You can't have a neutral compound when you put those two things together. So therefore, a common number that both of these things go into evenly is 6. So that means I need enough calciums to equal +6, and I need enough arsenate to equal -6. And so that is why I will need 3 calcium and 2 arsenate. Just be careful here because the 2, again, indicates that there are 2 arsenates, and you absolutely need parentheses around the polyatomic ions, especially if there is more than 1. If this was just a 1 out here, you wouldn't need them. But because we need to indicate that there are 2 of them, we need 2 of this entire thing. And so that's why you need to have the 2 outside with parentheses. This 2, however, does not go to the calcium. Sometimes students think that, but that's not true. The 3 is the only thing that reflects how many calcium there are. So let's get into actually naming and formulating here. So we have something called aluminum sulfite, and you want to be really careful with the name. Just like usual, you'll have to look up the charges of these individual things. So Al+3 will be the charge on aluminum, and then you may say, where do you get the SO3 from? Well, keep in mind, this is called sulfite. There is nothing on the periodic table that is called sulfite. So therefore, this must be something on the polyatomic ion sheet that you have. And so as it turns out, it is a polyatomic ion, and it is called SO3 or sulfite with a -2 charge. And then just like we did before, we'll have to make sure that the charges equal each other out. And then again, that will be the formula. Just be really careful to indicate the fact that we need 3 of the sulfites, and that's why we have the parentheses. Here's another example, silver sulfate. And if you're looking on your periodic table as far as what the charge of silver is, you may be a little confused because it's actually in the transition metals section. So this is where your periodic table comes in handy, because on your periodic table, I actually tell you what the charge is. So you should see a +1 there, and that would indicate that the charge on silver is going to be +1. So you have to use your periodic table to determine the charge on any transition metal. So that means silver is going to be +1. Sulfate is going to be SO4 - 2. Again, that is a polyatomic ion. And then, therefore, just like usual, you would need 2 silvers to balance out the number of sulfates. And so, therefore, it'll be Ag2SO4. You don't need parentheses technically around the SO4. However, my students just like to write them all the time just so they don't forget to write parentheses when they do need them. So it's really up to you, but you don't absolutely need them here because you only have one of the SO4. Here's another example, calcium bromide, Ca+2, Br -1. You need 2 of the bromides to equal out the charge on the calcium. So it'll be CaBr2. Lithium nitrate. Again, you want to look up the charges. Anytime you see an 8, again, that is not on the periodic table, so therefore that must be a polyatomic ion. And in this case, it'll be Li+1 and then NO3 -1. It's a 1-to-1. You can see it's -1 to +1, and so therefore, pretty easy formula, LiNO3. Again, parentheses are optional when you only need one polyatomic ion. Here's another example, and you're probably interested in this Roman numeral. Well, if you look to see where nickel is on the periodic table, you would see that this is also in the transition metals section, and you probably notice that there's actually more than one possible charge for nickel. The good thing is about this is that the Roman numeral will always tell you the charge and it will always be positive. So in this case, nickel 2 means nickel with a +2 charge, and nitrate is going to be NO3 with a -1 charge. In order to have the compounds form and have the charges equal each other, you're going to have 2 nitrates, and so that will be your formula. Do not think that this 2 represents the subscript for nickel. That's a very common misconception that students have, but that is not correct. Again, the 2 or any kind of Roman numeral will indicate the charge. Here's another example, iron 3 chloride. Again, if you look where iron is on the periodic table, you can see that iron could be 2 or 3, iron +3 or iron +2. But because this is indicating 3, this tells us that iron is going to be +3, and we already know chloride is -1, so we'll need a total of 3 chlorides to equal the charge on the iron, and therefore that will be your formula. Hopefully that helped you to understand how to name and formula write a little bit for ionic compounds. As always, you need practice, and you'll definitely get better at this. Thank you so much for watching.